let's go through this. These 6. We've talked about them. Let's go through them one by one. E to the ax, whatever. So for us to go through them effectively and perfectly, first we need to imagine also what answer we would get if we were to differentiate something related to these guys, except for him, okay? But for these other guys and for him as well, and for him as well. But you're going to see for the other guys, these 3, that we're going to talk about what you'd get when you differentiate, and it's going to be very much related to the integral. And also for these guys, we'll talk about what you differentiate to get them. For these 3, we'll talk about what you differentiate to get them, okay? So for the guys, I'm going to circle in blue. For the guys, I'm going to circle in blue, which is him and him and him. We'll talk about who we differentiate to get them. And then for him, we'll talk about what we would get if we are differentiated, and it helps us to know the integral. So these are the methods we're going to use. So in other words, we start with their derivatives. Okay, for all 6 of them, we start with their derivatives, and then we can be able to know their integrals. So here we have e to the ax plus b as the very first thing. So e to the ax plus b. Okay, now what is the easiest form of e to the ax plus b? We want to talk about its derivative. You see, we have f of x and f dash x. This is for derivatives, okay? And we use those. These are their common derivatives. Then here we can have our common integrals, which is the original function, which we've written in functional notation, f of x. And then the other one is the integral. So now let's go through this and let's make sure. So we have our f of x. What is it this time? All right. It doesn't make me feel good when I put this f of x here, because it kind of affects a lot of things. Maybe let me just put it as y. You know what I mean? To say y, then dy dx, because it can disturb us. Then here I can say, right, this we have y. Then here we have the integral of y with respect to x. Okay, or we can have here our dy. Then here the integral of that with respect to x. Okay. Right. If we can even call this dy dx, then say this is the integral of dy dx. We are integrating dy dx with respect to x. In other words, the integral. Okay? Whatever. Now let's start. We have e to the x as our first thing. What do we get as the derivative? We get e to the x. Then what about if I have now, when you differentiate e to the x, you get to the e to the x. What about if I differentiate e to the f of x? What would I get? It comes back as it is, e to the f of x, but then you multiply by the derivative of this guy. So it will be f dash x, e to the f of x. And this is a big statement for us, because it's carrying a lot. What this is simply saying, for whatever question you're going to get, we don't know the question you're going to get, but an example is this ax plus b. Whenever you get the power of e being something which is not x, that guy is a function. So I'm saying if we have e to the x is the only function there, and that's called an exponential function, right? If you have e to the x, it is the only function that's there. But now when it's e to the, say, ax plus b, we're going to remove that. If it's e to the ax plus b, then we are not saying we have only one function. Now we'll be having 2, because ax plus b alone is a function. It's a polynomial function, and we can differentiate it, whatever. And then we have this outside, which is e to the something. So the inside is ax plus b. This is the inside. So now we no longer have e to the x. We call that e to the f of x. When you have anything which is not x, we call that f of x, and we treat it as a function on its own. And it is the when we are doing the chain rule, we work with it as well. So here we start by differentiating outside, which is e to the f of x. It comes back as it is, because as you see, when you differentiate e, it comes back as it is. Then next we differentiate the bullet. So it will be f dash x. This is the derivative of that inside function, and it comes back as it is, e to the f of x. So we differentiate the inside function and we multiply. So we differentiate the inside function and we multiply with the derivative of the outside. Okay, and this e to the ax plus b is an example. They want you to remember ax plus b, but you don't have to cram it, because it's a type of f of x. We know for f of x, we were bringing it as it was, then multiply by the derivative. So that's the same thing you do. You bring it as it is, e to the ax plus b, then you multiply by the derivative of the inside, which is going to be the derivative of ax is a. So it'll be a to the ax. And that is what then gives us the solution when we are dealing with the integrals. Because when we deal with the integrals, we'd say, okay, what would it have been if I had e to the x? What is the integral to this guy? Well, the integral of e to the x is e to the x, okay? If I ask you to integrate e to the x, it comes back as it is. What about the integral of e to the f of x? Now, this is what you have to know, because it then helps you for that. What is the integral of e to the f of x? Well, the integral of e to the f of x, it comes back as it is. It comes back as it is, but then you multiply by 1 over the derivative of this. We were multiplying by the derivative, but now we are multiplying by 1 over the derivative, which is like to divide. What is the derivative of f of x? It's f dash x. So now we are dividing by it, okay? And that is what happens when we have e to the ax plus b. Okay, if we have e to the ax plus b, okay, this 1 over x, you can put it in front to say it will be 1 over f dash x. And this is multiplying e to the f of x. Then we have e to the ax plus b as our third one. What do we do here? Well, what you're going to do is the same thing you did with f of x, because ax plus b is an f of x. What do? I multiply by 1 over the derivative of the top if you just want to do it the long way. Okay, or we can say you bring it as it is. Since it's e to the ax plus b, then you bring it as it is. Okay, it would be 1 over a. All right, because that's the derivative of we divide by the derivative of the inside function. And the derivative of that inside function is the derivative of ax plus b, which is a. And that is what we divide. So this is going to be the solution for that. This is, we'll put a star on it. This is one of the things they want you to know, which is, what do you get when you integrate e to the ax plus b? It comes back as it is, but you multiply by the derivative. But remember to always put your constant of integration c at the end. Okay? You always should put your constant of integration c. Okay, that is going to be it. This is it for the first part. We'll go to the next part and we'll talk about it together. Goodbye for now.